Hello learners, let's do the last chapter of the book 2 of the HSC portion, that is probability distribution. I'm your mathematics guru Shivani ma'am, and I'm here to help you understand the chapter in a better manner so that you can perform it in the examination properly. Now this chapter, again, as I said, probability distribution is not only restricted to the HSC thing, it is also there in various other boards, and this chapter is again having a very high weightage and value. So probability is something which we all know. Probability actually means a chance. Now when we talk about a chance, there is a chance that maybe it rains tomorrow or maybe it doesn't. So for that we can say the chance is like 50-50, it can or it cannot. हाँ, ये अलग बात है कि हम अगर देख लें कि चलो मेड डिपार्टमेंट ने क्या बोला है उस हिसाब से हम चांसेस ले रहे हैं, that is a different case. But in general we talk about the chances which are more or less equally likely. Let's take a very basic example of tossing a coin. Now ideally when we toss a coin, the chance is like 50% time it should be head, 50% time it should be tail. And since ideally it is half-half, that is why we use toss in so many games to start. आपका क्रिकेट का गेम भी टॉस से स्टार्ट होता है, आपके जो नेट वाले गेम्स होते हैं उसमें भी साइड डिसाइड करने के लिए हम टॉस यूज करते हैं, so that we know कि okay we are giving a fair chance to both the teams. But experimentally when we go, this is not the case. I can tell you people to do one experiment कि आप एक कॉइन ले लो और उसको 10 बार टॉस कर लो. Now not necessarily कि आपको 5 heads या 5 tails ही आएंगे. There may be a case that you are getting 7 tails and 3 heads or 6 heads and 4 tails. So वो आपका probability का जो part है which we can't ignore because this is the also one part which is very important. That's the experimental probability. So experimental probability and the other one which I'm talking about which is giving you the equally likely chance, that is theoretical probability. So in this chapter when we are talking about the probability distribution first part, we are dealing with the theoretical probability concept only. So the theoretical probability says that when we toss a coin, it can either result in head or tail having equally like chance, or when we throw a die, then it will be either 1, 2, 3, 4, 5 and 6 equally likely chances and so on. So let's understand what exactly is there in your portion this year. So first thing is understanding of a term known as random variable, the various types of random variable and probability distribution of a random variable. Now this is one thing which we have not done till now. हमने जितनी भी probability पढ़ी हुई है, we have only calculated the probability. We have not formed a tabular distribution of that. So here we are going to deal with the tabular distribution of this probability values. Now using that we also calculate probability mass function, cumulative distribution function, expected value and the variance. Expected value is also known as the mean of the probability distribution function. Then we have continuous random variable, probability density and two different kinds of probability calculation methods. One is by binomial distribution जिसमें कि हम उनका mean and variance देखेंगे, and one is by Poisson distribution. Okay, so these are two different forms and then we have different formulae for that thing. So let's first start with the understanding of a random variable. So when we talk about a random variable, this is the variable which is given to a particular kind of experiment. So like tossing 2 fair coins, so we get 4 points, HT, TT. But ये आपका sample space है. This is not your random variable. Random variable comes into picture when we decide what we actually are looking for. So if we are looking for having heads, so the random variable can be 0 because 0 heads, then 1 head and max to max 2 head. तो आपके यहाँ पे जो variables उनके 3 option मिलेंगे आपके 0, 1 and 2. So similarly if we toss a coin 3 times, it will become 2 cube, 8 options आएंगे. If we toss a coin 10 times, that becomes 2 to the power of 10, 1, 0, 2, 4 possible outcomes will be there. So if we experiment जो है जो randomly select कर रहे हैं, say 4 items from a lot of 20 items, then it contains 6 defective. So here the thing we have to first see whether we are actually looking for the defective item probability or the correct item probability to get the final answer. So once we get the random variable, we'll find out the probability of that random variable to come to the answer. The types of random variable which is there as a theoretical part is discrete. Discrete means it has a fixed possible value from a countable set, which can be finite, which can be infinite, like 0, 1, 2. ये आपके discrete variables होते हैं. And continuous are the ones where आपका एक interval होगा and possible values उस पूरे interval में रहते हैं. Okay, so then in that case, like डेली टेम्परेचर, तो वो डेसिमल्स में भी हो सकता है, कोई भी वैल्यू वहां पे आ सकती है. स्पीड ऑफ द व्हीकल, वेट ऑफ द स्टूडेंट्स. नाउ नंबर ऑफ स्टूडेंट्स इन द क्लास इज डिस्क्रीट, क्योंकि नंबर ऑफ स्टूडेंट वो 1.5, 2, 2, 3/4 नहीं होंगे. इट विल ऑलवेज बी 1, 2, 3, 4, 5, but the weight of the students can be in decimal within a particular range as the real numbers. So once we get the continuous or the discrete random variable, we'll see how to calculate the thing and make a probability distribution function. So let's take one example to understand the probability distribution function. Here, let's consider the experiment of tossing a coin 4 times and defining the random variable x as the number of heads in 4 tosses. So we know that number of heads can be maximum 4 and minimum 0. So आपके random variables will go as 0, 1, 2, 3, 4 and we'll calculate the respective probability over there. For 0 it is coming as 1/16, then 1, 1/4, 2, 3/8, 1/4 and 1/16. The sum total of all these random variables should definitely be equal to 1. If it is not 1, then definitely there is some problem with this. We can consider that as a probability distribution. ये आपका एक key part होता है to understand the probability distribution. For cumulative distribution, हम overall एक value लेते हैं, like fx is p, x less than or equal to x, and which we can also calculate using summation or using even integration, because integration is also the sum total of the thing. So now let's do some questions to understand how we take a particular question as a probability mass distribution and probability distribution thing. So first thing here is seeing that the total is coming as 1, and second thing is this, seeing that every value is actually a probability value. Now probability value ranges from 0 to 1. Anything which is there in negative, anything beyond 1 cannot be a part of the probability distribution. So to understand it more, let's do some questions. Now let's see the first exercise to get the clear picture of the chapter. So let x represent the difference between the number of heads and number of tails obtained when a coin is tossed 6 times. What are the possible values of x? Now यहाँ ये x आपका random variable है, and we have to calculate the possible values of that random variable x. So here when we say that जो trial है आपका 6 times है, so 6 times में maximum क्या हो सकता है? All the values are heads या all the values are tails. So when we talk about the difference between the number of heads and number of tails, so case 1 will be 6 heads, no tails. So now the difference will be, this is the difference which is your random variable x, 6 minus 0 which is 6. Case 2 can be that you are having 5 heads. So if there are 5 heads, number of tails automatically becomes 1. So 1 tail and then the difference will be 6 minus 1, 4. Case 3 can be 4 heads. So automatically tails कितने हो जाएंगे आपके 2. So we'll get 4 minus 2 which is 2. Then case 4 will be 3 heads. So we are getting 3 tails. So in that case the difference is going to be again 3 minus 3 0. इसके बाद ये केस रिपीट हो जाएगा बिकॉज इफ वी आर गोइंग विद 2 heads over here, तो यहाँ पे आपके 4 tails हो जाएंगे. डिफरेंस आपका 2 आने वाला है अगेन, देन 1 head, 5 tail and then 0 heads and 6 tails. तो in these cases ये जो आपके डिफरेंस है, डिफरेंस में it's not that we have to take just the heads minus tails, difference can be anything over there. So we'll go with 2, 4 and 6 again. We won't repeat the value in the random variable. So हमारे जो final random variables आएंगे वो होंगे 0, 2, 4 and 6. So this gives you a picture. Okay, fine. How we calculate the random variable. Now the second question, which is the thing, second kind of question is to determine whether each of the following is a probability distribution or not. So I already told you there are 2 conditions which you have to see. First, that every value is a probability value, so within the range of 0 to 1. And second, that the sum total of the probability distribution values should be 1. Probability ka sum. So if we see the first question, very clearly we can see that each and every value of px is within the range 0 to 1. So it satisfies our first condition. Second के लिए we can just calculate sigma of px is 0.4 plus 0.4 plus 0.2, which is coming as 1. Therefore, this question is a properly probability distribution. Next one, आपको directly दिख जाएगा एक value यहाँ पे हो रही है minus 0.1. So when we are talking about a value which is minus 0.1, see I'm showing it again here, minus 0.1, and we know any probability cannot go in negative, so therefore this is not a probability distribution question. Fine. Now we'll go to the next part, the third one. They are the values can be there, sum is 1, therefore it can be. Fourth one, now z की value negative हो सकती है, probability of z cannot be negative. So if z is negative, don't think okay अब कैसे करें, ये तो नहीं है. No, we have to go ahead with the value of probabilities. See to it that the sum is coming up as 1 or not. See the second condition. If both the conditions are satisfied, it is a probability distribution function. So when we talk about this probability distribution function, the next part is from that probability distribution function, how to calculate the expected value and variance, or you can also say that how to form a probability distribution function also. So pehle we'll form the probability distribution function. Now let's see question number 6. A sample of 4 bulbs is drawn at random with replacement from a lot of 30 bulbs, which includes 6 defective bulbs. Now find the probability, the distribution of the number of defective bulbs. Now जिसका आपको probability distribution निकालना है वो आपका main probability होगा, जिसको हम denote करते हैं with small p. So p is the probability of finding a defective bulb. Probability of finding a defective bulb. Small p से denote होगा, p यहाँ पे अगर आप देख रहे हो तो there are 6 defective bulbs out of 30. So this is 6 by 30, which can be simplified as 1 by 5. Now if p is this, then what is q? Q is 1 minus p. That not happening of the event is q. So here q will become 1 minus 1 by 5, which is 4 by 5. So q here is not finding a defective bulb, which is a correct bulb. So the first case is when the random variable x is equal to 0. So when x is equal to 0, it means all the bulbs are correct bulbs. There is not a single defective bulb. So all the 4 bulbs, which is like the probability come as q, 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 which we take it as probability of x is equal to 0. ये पहला केस है आपका. So ये value आपकी बन जाएगी x is equal to 0 as q to the power of 4. We have already calculated the value of q, so we'll put it. It is 4 by 5 to the power of 4. Second case, when x is equal to 1. So when x is equal to 1, the values will range from 1 defective bulb and 3 correct bulbs. So that one defective bulb can be the first one, तो आपको ये option मिल रहा है. Can be the second one. So Q can come first, P and Q can be the third one, which is Q, P and Q, and can be the fourth one, which is Q, P. So in all the 4 cases, you can see that there will be 1 P and 3 Qs, but there will be altogether 4 cases. So it will come as 4 multiplied by the probability of P is 1 by 5 and probability of Q is 4 by 5 whole cube. So this will be your probability of x is equal to 1. Similarly, we'll go for x is equal to 2. So यहाँ पे आपके x is equal to 2. So here the values will be 2p and 2q. So when we calculate this, there will be 6 cases of this, pp, qq, pq, pq. So 6 cases, 2p's, so 1 by 5 2 times, and then 4 by 5 2 times. Okay. The fourth case over here is, I'm writing it to this side, that x is 4. So which is px is equal to 4 is all q's, all p's, which is what is our desired this here, 4p, which is 1 by 5 to the power of 4. So once we get all the 4 cases, random variables, then we'll make the probability distribution table. Don't think that your question is over at this stage. Your question is now to make the probability distribution table. Now this table you can make either in the horizontal form or in the vertical form. In case, if you're just supposed to make the distribution table, you can make it in the horizontal form. But in case, if you have to also find out the expected value and the variance, always make the table in the vertical. So in the vertical form, we are going to write the random variable thing x, and then the second column will be x is equal to the small x, the variables. So it is 0, 1, 2, 3 and 4. I missed out one value of 3. We'll just write it directly over here when x is 3. So यहाँ पे probability आपकी आ रही है. That is again the 4 chances where we are having 3 wrong bulbs. So 3 की probability 1 by 5 to the power of 3 and here 1 correct, which is 4 by 5. So using all this, we are going to make the final probability distribution table. So when it is 0, the probability is coming as, because all correct bulbs are there, so P of x is equal to 0, which we just calculated is 4 by 5 to the power of 4. P is equal to 1, it is 4 into 4 by 5 to the power of 4, 3 and 1 by 5, जो कि ultimately बन जाएगा again 4 by 5 to the power of 4. The next one is 6, 1 by 5 whole square and 4 by 5 whole square. The next one, 3 is going to be 4, 1 by 5 whole cube into 4 by 5, जो कि final again बन रहा है the value of 4 by 5 and then 1 4 by 5 whole square multiplied by 1 by 5 square, and the last value is 1 by 5 to the power of 4. So you can write the simplified values left hand side पे भी sufficient gap देके you can write these things. So this is for 0, for 1, for 2, for 3 and for 4. Put it into the tabular form to get your answers. So this is how we make the probability distribution for a given question. Now from the probability distribution, to find out the value of Ex is your mean or expected value. तो expected value के लिए हम एक direct formula use करते हैं, which is equal to sigma xpx. So we'll multiply these two columns to get the Ex value, and for the variance we use another formula which is e of x square, that again we'll calculate from the table, minus ex ka whole square. There's a difference between these two values. So that value is the variance. So now let's do one question to understand the variance part also, where we already have the given things. Okay. So let's take question number 11. Find the mean of number of heads in 3 tosses of a fair coin. Now mean is actually your expected value. So when we talk about the 3 tosses of a fair coin, पहले हम लोग table बना देते हैं. X can be 0, X can be 1, X can be 2, X can be 3. That's the maximum value of heads you can get in the 3 tosses. This is P of X is equal to small x. Small x means the variable which is changing from 0 to 1 to 2 to 3. Now, when we are putting this, when x is 0, there's just one option which is TTT. So this TTT is 1 by 8 because altogether आपके options 8 हो रहे हैं. To make it simple, आप sample space बना सकते हो before you start the question. For 1, it is 3 by 8, again 3 by 8 and then 1 by 8. When you make the sample space, you can get a better idea how to get that. The next thing is xpx. So your value of x is 0 here. 0 into this 0. This is 3 by 8. This is again 3 by 8 into 2, which is equal to 6 by 8. Don't try to cancel out 2 and 8. Addition में easy होगा if all the denominators are same. Here it is 3 into 1 by 8, which is again 3 by 8. So the expected value is sum total of this, which is 3 by 8 plus 6 by 8 plus 3 by 8. So that is 12 by 8, which is 4 by 3. So this is the sigma xpx which we are getting, and this is your expected value of getting the 3 heads, number of heads in the 3 tosses of a fair coin. So this part is the first thing which you are going to deal in this chapter in the form of probability distribution. Let's understand the second part. So previously we have seen the probability distribution function of a discrete variable. Now we are moving to the continuous variable. Since we don't have a fixed value for the variable, यहाँ पे हमें एक sum total sigma या फिर integration use करना पड़ेगा for the continuous probability function. So यहाँ पे आपके 2 terminologies important हैं, probability density function and cumulative distribution function. So PDF and CDF of the thing. So let's first understand the probability density function. So we calculate the things fx greater than or equal to 0. This is the first condition. The sum total has to be 1. Then for any real number between like A and B, it can be C or D, whatever you have to find out, the probability density between any 2 variables, we change the integration constant from this C to D to get fx dx. Now, completely the interval basically decides the probability density function. For the cumulative distribution function, we take again for any random variable till x, a to x, where definitely we get the value of x greater than or equal to a and fx is equal to 0 in case if x is less than or equal to a. So the CDF of a continuous random variable actually is a non-decreasing continuous function and discrete variable के लिए वो एक step function होता है. Okay, so we can calculate 1 by 1 every step पे वहाँ पे, like we have made the previous probability distribution things, but here we'll get the full answer together. We cannot divide it into step by step thing. Okay, so let's see one example to understand the question here. So let's take the example 3. Let's return to this where here fx is 3x square between 0 to 1. So cumulative distribution function जब आप ले रहे हो fx, capital Fx, it will range from 0 to x because that's the first value, 3x square dx. Now integrate, normally we'll get x cube minus 0 cube, the value is x cube. So we'll give the final answer, fx is 0 for x less than or equal to 0, x cube for 0 to 1, and at 1 the value will become equal to 1, which is the total value 0 to 1. ये first and last जो हैं ये आपके more or less fixed kind of answers होते हैं depending upon your variable value. So here also one more example, if you have to get the probability density function. For this, x cube by 4 for 0 to 2, cumulative distribution function आपका 0 to x के साथ बनेगा. So it's x cube upon 4 dx. We know the integration of x cube, it is x to the power 4 by 4. तो finally value आपको मिल जाएगी 1 by 16 x to the power 4. Now put the values x and 0, आपको final answer मिल जाएगा 0 to 2 के लिए x to the power 4 by 16. And then how will we write? Less than 0, it is 0. From 0 to 2, it is x to the power 4 by 16. And for greater than or equal to 2, it is equal to 1. Okay. So once we come to this way, we can give the PDF also of various values. Now, यहाँ पे since find k if the following function is a PDF of a random variable x, 0 to 1. So if it is a PDF, this 0 to 1 में this value has to be equal to 1. And we use this terminology and this concept that sum total of all the probability distribution function is basically the probabilities are 1. We are going to use it here to find the value of k. So k can be calculated at the end using this formula and we get the answer. So now let's see again 2-3 more questions to understand it clearly. For this question, let's see exercise 8.2. The first question asks, check whether each of the following is a PDF or not. So when we have to check, the first sub part I'm taking, they have given the variable 0 to 1 के लिए एक different value, and then afterwards that is the 1 to 2 के लिए एक different formula. So when we calculate the thing here, what are we going to get is 0 to 1, the whole probability function जो है आपका, that is your f of x will be equal to 0 to 1 fx dx plus 1 to 2 fx dx. So you can see this thing, यहाँ पे आप पहला 0 to 1 पे fx लाओगे value of x, then 2 minus x. So it is x dx plus 1 to 2, it is 2 minus x dx. Now we'll just simply solve, ये basic integration questions हैं, we'll be solving it using integration. We are left with here x square by 2, the value ranges 0 to 1, and here 2x minus x square by 2, and the value ranges from 1 to 2. So once you put 1, it is 1 by 2 minus 0. यहाँ पे when we are putting the things, the second one which we are taking into consideration is पहले 2 into 2 which is 4 minus 4 by 2, then 1 which is 2, and then sign will change to 1 which is 1 by 2 over here. So solve this final part. It is half plus 4 minus 2 plus half, which is coming as 1. Now since the sum total, or you can say sigma fx, is coming as 1, it is a probability density function. So we can check whether it is or not in the same manner. Second one, you can see fx is 2. यहीं से पता चल जा रहा है because कोई भी variable आपका जो हो रहा है, that probability value can't be 2, but you can still put it over here. जब आप इसको integrate करोगे, you will get 2x, put the value of 1, answer will come as 2. So it is not a probability distribution function. Okay, so that's how we are going to go with the first kind of questions. For the second ones, they might give you some values and ask you to find the value of k or the missing frequency or a particular range over there. So let's take question number 9 over here. The PDF of a continuous random variable is given to you. Fx is given as 3x square by 8 for 0 to x to 2. So determine the CDF of x. For determining the CDF of x, आप f of capital X लिखते हो, which is 0 to x. Then don't go till 2. It is 0 to x fx dx, which is your 3x square by 8 dx. So it is now 3 by 8 आप common ले लो, ये हो जाएगा x cube by 3, 0 to x. When we substitute the things, it is x cube by 3 cancels. So final answer will come as x cube by 8. So this is your fx, and now we have to calculate CDF of various things. Let's take the first one. So for the first one, it is 0 to 1, 3x square by 8 dx, and then it will be taken as again 3x cube by 8 into 3. Value ranges from 0 to 1, or you can say 1 by 8, फिर आप ले रहे हो 1 minus 0, which is 1 by 8. ये आप directly इस formula से भी ले जा सकते हो. For the second value, x is less than minus 2. It's not there, not possible, क्योंकि range ही आपका 0 to 2 given है, तो value will become 0. x is greater than 0, it means it can be between the range of 0 to 2. तो आप x cube की जगह पे 2 cube डाल के आंसर लाओगे, value will be 1. Okay? So in this manner, we'll be able to calculate the CDF of the things also, and which helps into getting even the variance and expected value. So in this particular one, this is the first thing. Now we are going to deal with another kind of thing, which is known as binomial distribution. So in case of binomial distribution, as the name suggests, bi means two options should be there. These two options will be the happening of the event and not happening of the event. Happening of the event will be denoted by the value small p, not happening by small q. ये variables हम change नहीं करेंगे, हमारी मर्जी से नहीं है. They are already given to us, p and q. So for any question, if you are having two responses, then that sort of trial is known as Bernoulli's trial. So an experiment that can result in one of the two possible outcomes over here will be the Bernoulli's trial. Now let's see कि वो आपके क्या two possible हो सकते हैं, happening and not happening. So it is also known as dichotomous because two word आ रहा है, और binomial. तो probability of success and probability of failure. Success को अगर हम P से denote कर रहे हैं, Q will be 1 minus P because it's the probability of failure. So we can see that if the probability of success is denoted by P, the probability of failure will be denoted by Q. Okay? Now, how will we apply this? We have been given a formula to calculate this thing. इसके लिए हम बहुत सारे number of trials को check नहीं करेंगे. One particular condition, when the number of trials are limited, then only we can apply the binomial distribution. बहुत ज़्यादा हो जाएंगे तो we won't be able to apply it in this thing. And we have a fixed formula for the binomial distribution thing, that the probability of a particular thing to happen, for the success or for failure to happen, is actually equal to the x successes out of n trials. When we are talking about this is the x successes out of n trial. So probability of x success is actually n by x. Now this, what is n by x over here? This n by x, when we calculate, it is your last year, if you remember, permutation and combination. So it is a combination of the things. Total n chances, out of that x successes, and then p to the power x and q to the power of n minus x. So this is the formula for the probability of a particular value in case of a binomial expansion. Now let's see one example over here. Let's see the first or second example. If a fair coin is tossed 10 times, what is the probability of obtaining exactly 6 eggs at least 6 heads, at most 6 heads. नॉर्मल वे में अगर आप कैलकुलेट करने जाओगे तो आपके टोटल नंबर ऑफ ऑब्जर्वेशंस यहाँ पे आने लगेंगे 2 to the power of 10, which is 1024. Becomes very difficult to do the values there or calculate the values there. So in this binomial method, we can directly apply the formula and get the answer. Now, how is this binomial expression indicated over here is basically this particular thing. X, then एक ये similarity का sign डालते हैं B n comma P. So n comma P means n is the total number of trials which we'll take into consideration. P is the probability of the success. So here in this question, n is 10 times because we are trying it for 10 times. Probability of getting a head is actually 1 by 2. So when we take this thing, P is 1 by 2. So definitely Q will become 1 by 2, 1 minus P. Now Px is equal to x is nx means ncx, P to the power x, Q to the power of n minus x. So first case, exactly 6 successes means we can go with 10 by 6, 1 by 2 to the power of 6 and 1 by 2 to the power of 10 minus 6. We can say this particular value, put the value. If you remember the combination formula, NCR is factorial n upon factorial r upon or division पे ही factorial n minus r. So factorial 10 upon factorial 6 and then factorial 10 minus 6 which is 4, 1 by 2 to the power of 10. Not necessarily that you'll come to the final answer all the time. If the value are like in higher power, then you can leave it in that format itself. But if it is calculable, we'll be calculating it to the desired answer. Second, at least 6 successes. Now, here the question is big. At least 6 means success can be 6, 7, 8, 9 and 10. So you have to calculate all the probabilities of these chances or these values to get the final answer. So 10, 6, 1 by 2 to the power 6 into 1 by 2 to the power 4. Then 10C7, 1 by 2 to the power 7, 1 by 2 to the power 3. 10C8, 10C9 and 10C10. Every time if you notice, since P and Q are same, तो उनके powers add up करके 1 by 2 to the power of 10 ही बन रहे हैं. So every value will ultimately or the final answer will ultimately depend upon the value of the NC6, NC7, NC8, NC9 and NC10 and you'll get the answer. At most 6 successes means 1 minus P x greater than 6. We have already calculated greater than 60 values. You can directly use them. No need to calculate it again if you have done it in the same question. So then you can just write a note in the side that okay, from the calculation taken from above. So in this manner we can calculate the binomial distribution thing. For the mean of the binomial distribution, which is your expected value, we have a direct formula. That is NP. Whatever is the value of N, whatever is the value of P, just multiply, you're getting the value which is the mean. So one of the easiest one over here, ये आपके 1 marker में भी आ सकते हैं, 2 markers में भी आ सकते हैं, and variance is NPQ. So just multiply Q with that, you are going to get the variance. Now let's do some questions to understand this thing in a better manner. Here we are taking exercise 8.3 to start with the things. Let's see one question, question number 2 here. So question number 2 states that a pair of dice is thrown 3 times. Now this 3 becomes your N over here. So N is 3. If getting a doublet is considered a success, find the probability of 2 successes. Now doublet means 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. Total number of possible outcomes when you are throwing a pair of dice is basically 36. So here P, which is the probability of success, is 6 over 36, which is 1 by 6. Therefore Q automatically is 1 minus P, which is 1 minus 1 by 6, that is 5 by 6. So your question becomes B, the value n 3 comma 1 by 6. This is the way we actually write the binomial thing over here to go with the question. If you see now, so how do we denote this? X, then a similar sign b 3 1 by 6. When b is written, then it's understood that we are actually dealing in binomial distribution. Now we have to find out the value for two successes. The general probability for x is equal to small x is equal to NCX p to the power of x q to the power of n minus x. This is the general formula. Now we'll apply this for x is equal to 2. We will get n is your 3 chances. ये आपको यहीं से मिल रहा है. 2 आपको चाहिए. p is 1 by 6 to the power of 2. q is 5 by 6 to the power of 3 minus 2. So 3c2 when we calculate is factorial 3 upon factorial 1 and factorial 2. This is 1 by 36 and this value will be 5 by 6. So your final answer मैं यहीं पे लिख दे रही हूँ because not a lot of calculation is required. यहाँ पे 3 मिल जाएगा. 3 into 5 15 divided by 36 into 6 जो कि कैंसिल करेगा 5 and 2, so it will be 5 by 72. So that is the probability of having two successes. One more question let's take for the values to get e by x. Now here, given that x, b and p, n is 10. Question number 9 I'm talking about. N is given to you as 10, p is 0.4. You have to find out the expected value of x and the variance of x. So if p is 4, q will be 1 minus p, which is 1 minus 0.4, that's 0.6. Expected value of x is np. This is a very small question. ये again आपके MCQs वाले 1 mark, 2 mark पे आते हैं. NP is equal to 10 multiplied by 0.4, which is equal to 4 expected value, and variance of x is NPQ. So this is 10 multiplied by 0.4 multiplied by 0.6, that will come as 2.4. So in this manner, we are going to deal with the binomial distribution. Now the last kind of distribution over here is Poisson distribution. You can see this. Poisson, definitely based on the name of the scientist over here. So Poisson distribution, spelling pe dhyan do, P-O-I-S-S-O-N. So in case of this Poisson distribution, we take the discrete value which has a very high number of chances to go with the things. Like abhi previous case mein n was 10, 5, 6, that sort of thing. But if the value of n is very high, we can't apply binomial distribution. Then the thing which comes into picture is Poisson. So Poisson के लिए हमारे पास again एक direct formula है, which is px is equal to x e to the power of minus m to the power of x by factorial x. Distribution को हम show कैसे करते हैं? It is x, p and m. Now m is the parameter over here and m is the mean value of the distribution. So when we have the value of this, now the question comes sometimes, okay, how will we calculate e to the power of minus m? So don't worry, the board is considerate enough to give you the value of that e to the power of minus m. And in fact, in that manner, it becomes very easy for you also to know what is the m in the question. So here directly given hai m is equal to 5, e to the power minus 5 is given to you, px is equal to 5 or px greater than or equal to 2. So px is equal to 5 पे हम directly value put कर देंगे, m is 5, x is 5, e to the power minus 5, 5 to the power 5, factorial 5, and the value will come as 0.0067 as given over here. 5 to the power 5 is 3125 and below factorial 5 which is 120, and the final answer will be 0.1745. In case if it happens that you are not able to do the final calculation or the calculation is like pretty big, then in that case, at least leave the answer in this format, in the proper lowest multiple k form mein. Okay, then you will be able to get the same marks. Okay, or minimum marks will be cut. If it is x greater than or equal to 2, we can write it as p 1 minus p x less than 2. Less than 2 is easier, 0 and 1 पे आ रहा है. Greater पे आप 2, 3, 4, 5, 4 values calculate करते, तो it is easier to go with the 2 values. So again put the formula e to the power minus 5, 5 to the power 0 factorial 0, e to the power minus 5, 5 to the power 1 factorial 1, and you will get the final answer. So this is the calculation for the Poisson distribution, and now let's do some questions for Poisson distribution. Let's see one question on the Poisson distribution over here. Say question number 3. If x has Poisson distribution with parameter m is the parameter over here, and then px is equal to 2 is equal to px is equal to 3, then find the value of px greater than or equal to 2. Here it's given e to the power minus 3. Now, when we know that parameter m is not given to you, we have to calculate that parameter. And here, a major hint है आपके पास कि ultimately whatever you calculate, the parameter will come as 3, and then you can apply the formula. So let's see, first thing which is given is px is equal to 2 is equal to px is equal to 3. So when we put the formula over here, x is equal to 2 pe, so we are getting e to the power of minus m to the power of 2 upon factorial 2 is equal to e to the power of minus m to the power of 3 upon factorial 3. In both the cases, e to the power of minus m will get cancelled, and then factorial 3 by factorial 2 will be left as m cube by m square. So here you can see 3 is equal to m, and then as I said, आप easily अपने question को solve कर लोगे by putting the values, and the values given to you. Similarly, if you see here, the second one, p1.2, then find px is equal to 3, and here also they have given the value of e to the power of minus 0.5. So when the value is directly given to you, you can easily put the things to come to the answer with the parameter and get the final answer. Now for this, again when you have to calculate the mean, तो mean आपके पास already है इस question में, which is m. The value of parameter itself is mean, and यहाँ पे variance is also m. So in this manner, this particular chapter can be done using first your probability distribution thing, making the distribution table, second calculating the probabilities, then finding out the mean, expected value and the variance of the probabilities, binomial distribution, and then ultimately the Poisson distribution. So this is the end of your portion for book 2. Whenever you are dealing with the paper, some tricks to calculate the things easily to appear for the paper. First of all, please write the paper in the presentable format. Start a new question from the new paper. Okay, mark the answers, highlight the answers so that teacher can see your answers over there. See, they are checking more than 100 papers in a day. If your paper is not presentable, if you are not highlighting your answer, they won't be able to judge the things directly. Now, if I can say, the difference between 4.5 and 5 out of 5 is basically your presentability. So the person who's getting 4.5 also knows the concept, but some point somewhere presentability में जा रहे हैं. So work on that thing. Whenever you're doing a question, please start the paper with the mindset that whatever you know, you have to do that first. Don't start searching for the paper. Okay, let's see the question which I don't know. So don't go with this mindset. See the questions which you know, do them first, and leave spaces for which you don't know. Don't think, do it at the end, because questions will be calculated within that section, within that particular question itself. So using these things, at the end you can come back, try those questions. If you are planning to do extra questions, first complete the paper and then only go to the extra question. So I'm sure all these series of videos which we have done for you people will help you in scoring very good marks for your grade 12. and all the best to you all. All the best from Shivani ma'am. And then I'm sure that you people are coming out with flying colors at the end. And please write this in the comment that how you liked the video and how it helped you people. Thank you so much. All the best.